Hello, everyone. First of all, thank you for coming to the session. I know it's one of the last sessions today, so I will try my best to keep you awake. I have one little thing to ask for. If you have a device on you, a mobile phone or a laptop, could you leave it in your pocket or in your bag during the session? It would help me very much in my presentation. And I won't feel offended if you go outside because you need to call someone or if you decide that this session isn't for you, but I prefer if there are no mobile devices out during my talk. So I will be talking about challenges of developing an open source operating system for mobile devices today. And before I give you a bit more context about myself and about the talk, I will do something that a lot of speakers do nowadays. I will try and find out a little bit about you as an audience. So are there any people in the audience who have changed the Android source code in the past, the operating system itself? One over there? Okay. And seeing it from the other side, are there any people in the audience that have been an app developer for Android apps in the past? That's quite a few more people. So that's very interesting because it gives me context, and it's actually quite good to see because it helps me adapt what I'm doing in the talk. So actually, let me give you a little bit of context about myself. My name is Jessica Hummel. I work for Google. I work on search at the moment, on exploring new features for search. But until the beginning of this year, I was working on Android, on the operating system. I was managing a team of close to 20 people that worked on enterprise functionality in the operating system. So for example, device management. If you imagine some employers don't want to allow their employees to access corporate data, such as emails or sensitive data without having a certain level of control over the devices that they are using for security reasons. So that's the area that I used to focus on until the beginning of this year. And that's also the context in which I've gathered the information that you will see now. So to give you an idea of what we're going to do in this talk, I've divided it roughly into 4 sections, and then there will be a short summary at the end. So first of all, I'm going to divide the title into its parts. I've intentionally not shortened it because I think it's a very long title, but it represents some of the complexities of developing an open source operating system for mobile devices quite well. So I didn't split it intentionally. After this first part, I would like to give you a bit more context on Android so that you can understand the third part, which is some real-life examples, which hopefully at that point you can relate to. So first, I would like to look at the different pieces of the puzzle. So I'm just taking apart the title, basically. And the first part of the title is just development. And it sounded to me like there's at least half of the audience is a developer here. Is that right? Who's a developer? OK, I'm not sure if I see anyone who's not a developer. So that's good. So you can relate at least to this part for sure. So in development, what would you consider a challenge? The everyday challenges that come to your mind. Maybe you can think for a moment before I give you what I came up with. So one of the things that I came up with is there's constant change, and code can get quite complex. And that complexity a lot of times contributes to debugging being quite difficult. Then also, most likely you will not be working by yourself. So you have to contribute to a code base. You have to merge in changes, which might overlap with other people's changes. And you have to make sure that everything stays consistent. And then, of course, everyone loves it. There's test coverage. You have to make sure that nothing breaks. So this is just general development, right? If we go on to open source development, just to make sure that we use the same terminology for open source means that someone develops code and allows other people to use it for their purposes. There are different licenses. So in some cases, open source means if you use it, then you have to make your code open source as well. But in some other cases, like Android, that is not the case. For example, in Android, someone can take the Android source code, can change it, and can sell that as a proprietary code. So if we think about open source, there's additional challenges. So for example, open source means that a lot of people can contribute to the code, meaning that there's even more people merging changes in. It also means that everything can grow much faster and it can spread more, which is actually a good thing in the case of Android, because that's why so many devices have the same operating system. Then, of course, if that many people are contributing, what happens to the vision? You have to make sure that everyone works towards a common vision and make sure that everything is consistent and isn't fragmented. And when I talk about fragmentation in this talk, what I'm referring to is that there's many different versions that don't quite do the same thing, potentially, but hopefully they do. And then you also have to consider security, because if there are a lot of contributors, you have to be even stricter about what goes in and how this could affect security, so that you make sure that Android as an operating system is secure, even though that many people contribute. Now, Android is not only open source, it's also an operating system. As an operating system, it has different challenges. And maybe someone from the audience can make a suggestion for a first challenge. What would really, sorry? Hardware compatibility, yes, that's a good one. As an app developer, yeah, in the back. Updating, yes, updating is actually a very good one. That will come up later as well. As an app developer, what would you be really annoyed with if it wasn't the case? Sorry? Resolution, you mean the different screen resolutions, or? Yes. Yes, versioning, backwards compatibility. And generally, you want it to be stable and you want to have a nice API surface, right? Because if the operating system doesn't work, then nothing else works. And then the final part of the title, before we go into specific Android cases, is mobile. Mobile has its own challenges as well. So for example, resources are very limited. You have a smaller screen, you have less resources in general, you have to think about battery life. All of those things impact your coding, because you have to, when you write something, you have to justify everything, because you can't just have 1 hour less battery just because you add a fancy new feature, for example. And then, yes, actually, it was already mentioned, different screen sizes can be a very good challenge for mobile as well. And then, again, there's fragmentation, because as a developer, has anyone of the app developer come across special cases where they had to special case different OS versions because an API wasn't available on all of their? Yeah, I see one hand there, another hand there. Yeah, so that's another challenge. So this is just an overview of what comes to mind first when you just hear the title, right? The next step is to look at Android and see what specifics Android gives us. And I will give a little bit of context, a little bit of knowledge about how Android works. This might be repetitive for some of you because you have some Android background, but I think it's necessary to understand the real-life examples at the end. So Android consists of different layers. There's the Linux kernel, which is open source as well. Then there's the hardware abstraction layer, which allows access to the hardware through Java interfaces. Then there's the Android runtime, which allows apps to run and translates their code into native code. A few native libraries. And then there's the Android framework. That will be the part that I'm referring to when I use the term Android in the future. And the Android framework is used by the applications so that they can implement their applications. To make sure that you understand what the framework is basically a set of building blocks for application developers. It's a lot of different functionalities for UI. It provides views, for example, that the developers can use so that they can shape their UI. It also provides like a backstack, which is implemented through activities, which most of you are familiar with, and a lot of other functionality. I don't want to go into too much detail. The summary is it's building blocks which are available through APIs. Then there's a few other details. I mentioned the licenses earlier. Android is under the Apache 2 license, which means anyone can use it, and they can also make it proprietary code, meaning they can make it closed source and use it for their purposes without having to give the code to everyone, to the public. Anyone can use the Android code, but also anyone can contribute to the Android code. But we will see a little bit more about that in the future in this talk. And then the reason why this license is so important for Android is that all of the large manufacturers, the OEMs as we call them, original equipment manufacturers, Samsung, LG, Sony, all of those run Android on their devices. And they all contribute to Android, but they want to keep their implementation as their proprietary code. So if Android wasn't under that license, then the spread of Android would be much smaller and there would be much less consistency across different phones. And finally, the release is a yearly release, and sometimes there's some patches in between. The API level sometimes goes up as part of those patches, and there's monthly security releases as well. Now, another aspect, which I'm not sure as app developers you are familiar with, is that there's a lot of different players in the ecosystem. And all of those players, when it comes to the operating system development, have different opinions and different interests. That's why I'm listing them here. So first of all, you have the chip manufacturers. Then you have the OEMs, the original equipment manufacturers. As I said, it's Samsung, Sony, and the likes. Then there's also the carriers. For example, carriers will often have an interest in shipping devices with a large set of apps, because that's how they make their money. But then, as an ecosystem, we have an interest in not shipping too many apps to people because they have overloaded phones and they can't do anything with it because they don't understand what all of this stuff on their device actually is. Then there's app developers, like most of you here. And there's also GMS Core, which is some software developed by Google, which makes sure that functionalities that cannot be in the open source code function. And GMS Core is installed on all devices that have Play, because only if GMS Core can be installed, the apps can use Play. And then there's the end user, of course. And it's very important to mention that, because the end user should be the absolute priority for all of us, right? And that is not necessarily always what happens, because there's so many people with different interests who push for different APIs. And just to visualize a little bit where some of those challenges lie, this screen size fragmentation. If you just look at it, you can see there's many different devices with different screen sizes and with different resolutions as well, and all of those have to be catered for. And the aim of the framework is to keep it as simple as possible for the app developers and hide as much complexity as possible, which is not trivial. Besides the screen size fragmentation, there's also the OS level fragmentation. If you look at this, I think there is a pointer somewhere in here. Well, anyway, if you look at this, you can see that, for example, 14.5% of devices are still on KitKat. So that's an operating system which is over 4 years old. If you think of your app or any app you've worked on, is that a good thing? Like 4 years old software is quite a challenge, right? And for any version that is here, you still have to support that version, and you have to make sure that everything still runs on it. And this might be my favorite image, just because it looks nice. This is a representation of all of the different devices that run Android that are out there at the moment. So I think it shows quite nicely where the challenge lies, because for all of these devices, the framework wants to make all of the apps that run off these devices run perfectly well without having too many corner cases or having to cover too much of extra stuff. You can see you have the different manufacturers on here, and there's also the tail end where you have a lot of tiny manufacturers, mostly in Asia, who, whose name I probably haven't even heard. Right, so this gets us to the next step. I mentioned a lot of things which are a challenge for the development. So what does Android do to keep the chaos at bay? Because if that many people contribute, if there's that much fragmentation, if so much stuff is happening constantly and everything is changing, how can we prevent that all of this just goes completely crazy? There's a few things here. One is the contribution itself has to be regulated. Developers have to decide very well what features go in, and for that purpose, everything that people want to submit, no matter if they work for Google or if they're external developers and they want to contribute, every single change has to go through the same review process. And that review process is complex. It takes a long time. It's very strict. It will ask questions like, why do we need that feature? Is that feature in line with everything else that goes into this release? What are the security aspects? That's a completely separate review. It will ask, is the documentation good enough? It will ask, is the testing good enough? And for each of those steps, there's a separate review. And it's for a good reason, because otherwise consistency can't exist for a system like Android with all of these devices. Yes, I want to just highlight the last point again. Documentation, for example, is a feature in itself. I've seen code change as well. Documentation changes in the code take over a week to get agreed on, because every word matters, because if the developers can't understand what an API does, then it's used in the wrong way. Or if an OEM doesn't understand what it does, then they might change it in some way and it doesn't work properly then. Then equally important, or even more important, is testing. There's a whole set of different tests that OEMs have to run before they can call their devices Android. The first one is the CTS, compatibility test suite. Can I see who has heard of CTS tests? I see a few hands in the back. Yeah, so I'm glad that I'm telling you about them, because they're very important. So what CTS tests do is they make sure that all of the APIs work as they should. So the way you can imagine it is, for example, some APIs are developed inside Google. They go out with the release. They go to OEMs, to the manufacturers, like Samsung. And Samsung thinks, oh, that API, I don't like it. I'll just change it. So if they did that, then an app developer comes along and they write an app which runs perfectly on a Pixel, for example, and the moment it goes out onto a Samsung device, it's broken. So any OEM that wants to call their device Android has to run CTS to make sure that that's not the case. CTS verifier is the next step, where in some cases you can't automate everything. You can automate some things, but not everything. So CTS verifier is an automated, a half-automated test, I would say, where a person is led through manual steps to ensure that everything is as it is. So the way you can imagine it is something pops up and tells you, please check now that the settings show this. Like something is called automatically, and then you're told, please check that this looks like that. And this is, for example, for some UI features, it's not possible to check it in an automated way that's strict enough to make sure that everything is still consistent. Then the next one is CDD, compatibility definition document. I'm glad I managed to pronounce it, because it goes wrong almost every time when I try. This is for features that cannot be implemented in CTS tests, but they can also not be tested with CTS verifier. It's something that you can just describe to someone, and you want to document it somewhere. So in theory, everything that's in that document, the OEMs should not change either. But it's written text. There's always room for interpretation. So anything that can possibly go into CTS or CTS verifier really, really should. But it's not always possible. Then this is kind of, these are the top ones that I would say are the most important from the perspective of the framework for now. But I wanted to also include the other two, because in the examples I'll give later, they will play a role. So GTS is the GMS test suite. What it means is that any device that passes those tests is Google certified. It means that Play is installed. It means that certain other functionality that is part of GMS Core, which is the software package I mentioned earlier, that functionality is functional. And that means that a lot of things are supported for applications that are installed. One example would be authentication. So authentication with a Google account is part of GMS Core. Then also OTA, over the air. So that's the updates, which we actually heard about earlier as well. So those functionalities are implemented in the GMS Core part, not in the framework, because they can't be in the framework because they include proprietary code. And if I say proprietary code from the Google perspective, anything that includes the word Google anywhere cannot be an AOSP. So if it's a Google account, it can't be an ASP. That's kind of the short summary of what can go there or what can't from the perspective of Google. And then the vendor test suite is the last one I want to mention here. This is a relatively new one, which was introduced recently because there were really big challenges for pushing out new releases. And in some cases, if you think of a security fixes have to go out quickly, right? But if something breaks, then the AOSP is adapted, then it goes to the OEMs, and the OEMs have to wait for the hardware manufacturers to get some of their software before they can ship it. What happened it was called Project Treble. Oh. Yeah, so what happened there in Project Treble was that they separated those two layers so that there's an additional test suite which is running between those two layers so that the framework is now independent of the software that is needed to access the hardware. So that the framework can ship and they know it will still work even if changes are done in the hardware layer. And this, again, just to emphasize that this was important for the security fixes because it means that security fixes can go out fast because there's not as many parties that they depend on. So this is, I believe, the context you need to understand the examples, which I think are actually the most exciting part of this talk, because they give you a feeling for how crazy it can sometimes be, and I hope that you can relate to it a little bit as well. So the first example is just after a release goes out to OEMs. So imagine you've worked really hard. There's this release coming up. You work long hours because it's a one-year release cycle, right? So it's not agile at all. It's the opposite of what you do when you work on a small app, for example. You have this big release. It all goes out. OEMs look at it, and you get a bug report, and it says it's broken. Just to take a random example, maybe the package manager doesn't find packages anymore. You try and figure out what's happening. So you try and reproduce in the AOSP code. It's working perfectly fine. You can't find it. You go back to the bug. You ask for more information. They give you more information, but they can't really give you much because it's proprietary code. They've done some changes, and they can't give you those changes because that code is owned by Samsung, for example, or by Sony, or by LG. So after a while, you decide, okay, maybe we have to have some kind of conference because there's no way of figuring this out, but the bug seems so bad that maybe there should be a direct communication, which is unusual. You set up a conference. The only technology you have in common is the phone. So you start debugging over the phone, where you have about a 3-second delay because it's in a different country. You can't see the code, and you try and debug. There might also be a language barrier because sometimes if you work with a different company, they might be in a different country. Their English might not be too strong. And you spend a few hours on the phone. So what do you think the reason might be for a bug like this? Misunderstanding could be, yes. It's even a little bit worse than that, I would say, in this particular case. So what happened, and this is not the exact example as it happened, but it could have been. But what happened in the real-life example is they tried to optimize, let's say, for battery life. They removed some code. They didn't notice that they removed some code because there was a CTS test missing. And the whole system is quite complex, so they don't fully understand what's happening. And anything that is not CTS covered, they presume is not really necessary. So this emphasizes how important it is that the coverage is really, really good. And also, just as a small anecdote, I've also heard some rumors about test reports coming back with typos in them. And I think automated tests don't usually do typos, so I think there's a little bit of cheating going on sometimes. The second example. No, we missed a security bug. Really bad thing, right? There's a security hole somewhere, and you think, okay, we have to push this out quickly. We have a fix here. We've worked through the night. It took us 24 hours. It's fixed, right? Not quite. Because, as I said earlier, it's very difficult to get something out to the actual devices. It's not just you submit it. You have to create a separate branch for Android. You have to then push everything out. You have to go through the whole release process, which is again very strict because you could introduce a new security bug, for example. And then you have to get it out to the OEM devices. And it is to a certain extent up to them when they push out the updates. So it can take quite some time. And that's why in recent years on Android in general, there's been a very strong focus on security. So anything that goes in, there's security reviews that take a long time. There's always several people and several specialized people looking at all of the changes as well. And that's one of the reasons why releases take so long. There's also been a lot of effort into making the releases for security patches much faster. So that for most of the major manufacturers, they're monthly now. Right, so this is not really representative, but I put it there because it was funny. So one of this is basically how many lines of code I submitted in my career at Google. And we looked at this with some colleagues recently, and these were the comments that came up. And yeah, there's being a manager because I managed the Android Enterprise framework team, but there's also the Android release. And this is not actually an Android release, but it could be almost. So the reason is that, as I said, everything has to be very strict to make sure that nothing breaks, that we have the stability that we want, that everything is consistent, that everything is tested well enough to avoid examples like the one that we heard about earlier. It means that a lot of times you will start implementing a feature, or you will start thinking about a feature, you will maybe prototype it, you will then have to write, that has to go through review. Then you also have to write a design doc. That will have to go through review. You will have to write a security design doc if it touches security in any way. That will have to go through review. You have to look at all of the documentation. If the documentation isn't there, you can't submit your code. And all of the APIs have to go through review as well. So it can easily happen that you start working on one feature, and 5 weeks down the line, maybe you submit the first small change, which adds a string or something. And then later on, you will probably have a bunch of work that you do quite fast, one after the other, because then all of the reviews are done. But you also have to plan ahead a lot, because obviously it's a large release, so you can't submit everything the week before the release. So planning is extremely important, even more than in other projects, because you have to make sure that that is not the case. And this was actually not an Android release, it was me doing a product management rotation where I worked as a product manager instead of an engineer for some time. So this is, I have 2 more examples, or 2 more stories from real life. So in this story, I want to talk about a feature that cannot be implemented just in open source. I mentioned some things earlier, for example, authentication, or the updates, the over-the-air updates. Those are implemented in GMS Core for the feature that is implemented by Google, right? So if you want to implement a feature in the framework that includes something like OTA, like over-the-air, the updates, then it's very likely that it cannot be fully implemented in the framework. This causes a few different problems. One problem is you have to make changes in GMS Core as well. So that's an additional team, which is also very strict. GMS Core has to be kept small, because you don't want this chunky, it's on all devices, right? You don't want something that's big on all devices. Meaning that, again, they will be strict about their features. You have to try and get your part of the feature into GMS Core so that it can be supported. And all of that, of course, also has to be tested. Then tests are split between the framework and GMS Core. So that's kind of, and then of course, everywhere where something overlaps, it can also, testing is very difficult because you don't want to test everything in end-to-end tests. Or in like large tests, you want to have everything modular, right? And then of course, this is one implementation in GMS Core. But you also have to make sure that the same feature can work on different devices that have a different implementation of what is in GMS Core. One example is Samsung has their own update mechanism, or a lot of different large manufacturers, they will have their own update system for their OTAs, for their updates. In that case, you have to make sure that you somehow document and test as much as possible that all of the functionality works. But for example, what they could do is they could have their own OTA system, over-the-air system. They could implement that. Everything in the framework passes CTS tests because all of the APIs in the framework work perfectly fine. All of the GTS tests pass because the GMS core implementation works perfectly fine and GMS core is there. But they use a completely different package to actually do the over-the-air, the update. So you have to communicate with them. You have to, this, for example, would go into CDD, into the documentation, where you just describe what has to work. And you have to rely to a certain extent on those manufacturers to do the right thing and make that feature work. Now I have one final example which I added today, actually, because I talked to Zoran and Morten, who are giving a talk right now in this moment. They're working on resource overlays. Resource overlays are a way of updating resources dynamically. So for example, you could update images or strings dynamically. And they've been adding this to the framework, and it's now in O. It's available for some of the system components that they can use it. But they've been working on this since 2010. So they've been working on it for 7 years because it's a complex feature. And as I said earlier, Android has to be strict about what features go in. Everything has to be really sanity checked in so many areas, so that getting something like this in, which is a large feature with many different layers, requires several releases for it to go out. And it requires the developers to be very insistent as well. And everything goes through that strict review process. And when I was talking to Zoran about it, I was saying, this is the perfect example. I've replaced one of my examples with this one because I think it reflects how not only the internal team, but also external contributors face a lot of challenges, which they have in common with the internal developers. So I just wanted to go back to the beginning. I talked about the different parts of the title and what challenges this brings. And just wanted to highlight, in these examples, we've seen a lot of these different things. For example, we have seen that code complexity can cause problems. Like, for example, in the first example, where they just removed code from the package manager, if the code had been really simple, they would probably not have removed it because they could have understood immediately that this is something you should not remove. Then debugging, I'm just thinking about debugging over the phone. If you've ever tried it, if you haven't, you're lucky. Then yes, merges. We've talked about the different contributors, about Zoran's and Morten's project as well, where all of the merging can cause a lot of problems. Consistency is what all of this, everything I talked about, is driving towards consistency, right? That's the one thing it's aiming for. Oh, sorry. Then we talked about stability, and we saw that consistency and fragmentation really impact the whole ecosystem. And there's much more. I think we can find almost all of what I said at the very beginning in the examples that I was just talking about. And before I give just a very short summary of everything we've talked about, I have one little thing to ask from you. I would like to take like 30 seconds to 45 seconds to think about an example that you have come across where something was challenging. Maybe it fits into one of these 4 buckets. Maybe it doesn't. If it doesn't, that's fine as well. But I'll get back to you in a minute and explain what it's for. So if you can take like 45 seconds maybe and just think about an example of your own. And if you have an example, maybe you can raise your hand a little bit like this so I can see who's got one. And no worries, I won't ask anyone to come on stage. So can I see who's got an example in their mind? You won't have to say anything, just... Okay. So there's an idea behind it. Actually, it would be nice to share one in the larger group as well. But I will explain in a second what the thought was behind it. But maybe we can share one example or two examples if people are keen to share in the larger group. Yeah. So there was, on that specific device, there was the logcat didn't have the timestamps, and you couldn't figure out what was happening because you didn't see that there was a delay. Yeah. That's a nice example, actually. Yeah. Okay, I'm going to give a quick summary, and then you'll see where the whole thinking about your example, your own example, is going. So just to summarize everything, we talked about a few different things. We talked about what an open source operating system for mobile devices is aiming to do. We talked about what the challenges with that are and gave some context to understand the challenges. And then we also talked a little bit about approaches to handle those different challenges. So the aim is to have a stable operating system that is consistent, has simple APIs, and is widely spread. Because for app developers, for example, it's very important that the same operating system is widely spread. So it's bad enough that as developers you have to develop something for Apple, something for Windows, and something for Android. Then as challenges, the main ones we've identified are around consistency, around fragmentations, fragmentation, screen fragmentation, OS-level fragmentation, device fragmentation, manufacturer fragmentation, many different fragmentations. We've talked about the interest groups, where there's many voices and everyone wants different things, and they're pulling in different directions instead of having one shared vision. And we also talked about the challenges of the actual development, where everything takes long, where you have to go through a lot of reviews, but it's also for a good reason, because consistency is very important. And then as approaches, for the wide distribution, the approach is to make it open source, but to under the Apache 2 license, so that this code can be used for closed source code as well. Then for making sure that nothing breaks and it stays consistent, we talked about the modularization between the hardware layer and the framework. We also talked about test coverage, CTS, CTS verifier, GTS, CDD, VTS. I forgot one, I think. And then we talked about the review process, where everything is strict and where there's people who have a lot of knowledge about Android who sanity check what everyone submits and make sure that there is one shared vision and that Android as a whole makes sense, in particular to app developers like yourselves. And with that, I'm coming to the end of my talk, and there's one last thing that I want to suggest. It's an invitation, you don't have to do it. So I believe very strongly that at events like this, one of the biggest benefits is the shared knowledge between all of the people that come there. So what I would like to invite you to do is, when you leave the room, there's some space on the right where there's a few tables. So if you're interested in sharing some of your experiences with other people, for example, the one thing that you thought about earlier, then just stay in that corner, and I would encourage everyone to talk to one person at least, or maybe two people you haven't spoken to before, and ask them about one challenge that they have encountered. And if you didn't think about something earlier, you can still come up with something. I'm sure everyone has had some kind of challenge. It might fit into this talk. If you don't know one that fits into this talk, then share something else. I think talking to people is one of the best things you can do at an event like this. And that's the end of my talk. Thank you very much.